So today I'm just going to be going over this custom FPGA board that I designed following a Digilant reference manual. So this is an 8-layer board manufactured by JLC PCB. So I'm just going to be going over briefly over some of the peripherals I have on here, and I will be doing further videos showcasing my bring up steps for some of those peripherals. So just starting here, we have our DC barrel jack input. Allows 7 to 15 volts over here, and that goes into this buck converter that steps that down to 5 volts regulated, which then feeds into this quad buck converter that gives us our 4 different voltage rails that we will be using on this board, namely 3V3, 1V8, 1V0 and 1V5. 1V5 primarily being used for our DDR3 interface there. And here we have 2 slide switches over here. And right above that, we've got 2 RGB LEDs over there. And just right next to that, we've got 4 push buttons and 4 different LEDs just right above that. And just right above that as well, we've got our Toslink connector, a Toslink receiver and transmitter that connects directly to this FPGA fabric over there, the programmable logic of that. And that's not been populated yet, but I will get to that at some point. And just over here, we have our DDR3. It's an A16-bit bus width. I probably will be upgrading that considering the amount of room available and the fact that this is an 8-layer board. I will be upgrading that to effective 32-bit bus width. So basically just adding another IC over here, shift that up a little bit, move that down. And yeah, so this is our FPGA over here, our system on chip. It is the Xc7z020 speed grade 2 Zynq processing system. And just right here, we have our soft reset, resets the programmable logic of this FPGA. And just back down here, our system reset resets the processing system, the ARM core. And here we have 2 PMOD connectors over here. We have our 40-pin Raspberry Pi compatible header over here. And we have our HDMI in and HDMI out over here. And we have our boot mode selector switch over here. We can boot from JTAG, QSPI, or SD card, with JTAG being primarily used to program this FPGA. And just over here, we have our USB host. We have our USB to UART to JTAG connection over here. You can program the board via USB through this FTDI chip, converts that to JTAG signals that feeds into this FPGA directly. We also have this 6-pin exposed header over here. If you have a Digilant HS2 header, you can plug that directly in, and you can use that to basically program the board via JTAG. And over here we have our audio out, and we have just right below that our Ethernet connector and Ethernet PHY over here. Ethernet connector obviously not populated yet, but we'll get to that as well. And for some of these interfaces available here, we will be making a video just kind of showing my bring up steps for those. For the next video, we will probably be starting with the DDR3 and the QSPI after that, and we'll see where we go from there. Just going back over here as well, we can power the board via USB or this DC barrel jack, or we can power the board through this 40-pin Raspberry Pi connection here through that 5-volt connection. So you just have to move your selector switch, 3 different positions you can put those in. So yeah, just going to the back of the board now. Just on the back of the board, we have our SD card slot over here. We have a couple of oscillators over here, our processing system oscillator, Ethernet oscillator over here. A USB 5 is just over there. And as you can see, we have a lot of decoupling capacitors right under that BGA, mostly 0201 parts over there, some 0402. And we have the bulk capacitors a little bit towards the outskirts of that BGA. Those are allowed to be a bit further. So as you can tell, those are these 0805 capacitors over here. And yeah, we have our decoupling for our DDR3, mostly 0201, just right below there. So yeah, that should be it for the back of the board. Let's just go back to the front here. And what we're briefly gonna do is a quick power test for all the voltage rails we've got available on this board. So I've got my multimeter on the side over here, so I'm just gonna bring that over. And so we're gonna power the board via this barrel jack first. I'll move that selector switch to regulate it there. So let's just get this over here and connect it. And we have our power good signal that goes up. As you can see, I already have this I have this boot mode switch moved over to QSPI. I have verified the QSPI works. That's why you can see all the LEDs flashing. The board's already been programmed via QSPI flash. So I'm just gonna verify our voltages and see what we get. So let's turn that on there. So I have an exposed ground pin and some exposed pins for the various voltages as well. So that's 3V3 right there. 1V5 right there as well. 1V0. And 1V8 should be right here. So there we go. That's all good. And just gonna power the board down now. Take out this barrel connection. I'm gonna move the selector switch over to USB. Just gonna verify that the USB connection works as well to power the board. Just gonna plug that in. Power good light comes on. You can see the program running as it is right now with the LEDs and RGB LEDs. In the next revision, I'm probably gonna move this power good signal a little bit below here. But anyways, that's it. So for the next video, I will be going through my workflow on Vivado and Vitas for the DDR3 bring up.